let's revisit this concept of rationalizing the denominator. So recall what it does is when you're given a fraction and there's radicals in the denominator, the task is to find a fraction which has the same value, and the key is that it has to have the same value. However, the new fraction of same value should have no radicals written in the denominator, and there might be some radicals written in the numerator, but at least no more radicals in the denominator. So let's look at an old example that looks like this: 5 over root 7. You can keep the value of the fraction the same by multiplying by root 7 on top and bottom, and this will turn into 5 root 7 over 7. Now, if we look at rationalizing the denominator in the fraction 5 over 3 plus root 7, a thought would be, based on what we've seen earlier, to multiply by root 7 on top and bottom. So here the parentheses would be required around the 3 plus root 7. And then if you distribute in the denominator your root 7, you'll have the denominator read 3 root 7 plus a plain old 7. The numerator will still be 5 root 7. And the root 7 on top and bottom will not cancel due to the plus sign in the denominator. So we still have a radical in the denominator. We're kind of stuck, at least trying this. So it's a good idea, it just didn't work. Here, please note that the denominator consists of two terms, 3 plus root 7. So the plus sign separates the two terms. And so in this case of having the two terms, we'll have to do something a little different. So here's a new strategy. If you must rationalize the denominator and you see two terms in the denominator with either or both having a radical, then step 1, multiply the top and bottom by the conjugate. Step 2, FOIL in the denominator, and that will all work out. The reason it's going to work is when you FOIL, the outside and the inside terms in your 4 terms of FOIL are going to be opposites, and they will cancel each other out. And in the first and last of the FOIL, you end up squaring away radicals. So the key step really to recall for this strategy, I know it looks rather long, but the key thing to recall is to multiply top and bottom by conjugate. What do we mean by conjugate? 3 plus root 7 and 3 minus root 7 are conjugates of each other. So let's take a look back at the example we just got stuck on earlier. We'll rationalize the denominator in 5 over 3 plus root 7. So instead of multiplying the top and bottom by root 7, which we saw just a moment ago didn't work, we're going to multiply top and bottom by the conjugate. So there's this 3 plus root 7 here. The conjugate is 3 minus root 7. We'll multiply by that on top and bottom. So at least one time we should show all the work. I did not distribute in the numerator, just left it the same, 5 times quantity 3 minus root 7. You can choose to distribute if you'd like. The denominator is the key though. Here we need to FOIL, as step 2 tells us. We'll have 3 times 3 is 9. We'll have a minus 3 root 7. We'll have a plus 3 root 7. And then you have a root 7 times a negative root 7. So that'll be a negative. But the key thing is a root 7 times a root 7. Look, you're taking a radical, multiplying by itself. That's going to be a plain old 7. That's what we mean here by squaring away radicals, right? So root 7 squared ends up being a plain old 7. There's a more radical. And you might say, well, wait a second. There's radicals here in the second and third terms of this FOIL, but those are the outer and inner terms. They are, in fact, opposites, as what you see here in red. Mentioned in the strategy, you have a negative 3 root 7 and a positive 3 root 7. Those two things will add up to a 0, so that's basically gone. In the denominator, you're really just left with 9 minus 7, which I simplified to a 2. Again, in the numerator, if you want to distribute that 5, go for it. Whether you do or not, I'm not really all that concerned about. The key point is we really truly do have a new fraction whose value is exactly the same as the original fraction. These are equal even if they look different. And the key point is, hey, at least there's no more radical in the denominator. That was the key task of rationalizing the denominator. Sure, there's a radical in the numerator, but we're going to take that, right? So the whole point was, can we rewrite this fraction, something of equal value, where at least there's no more radical in the denominator. And yeah, that is 5 times quantity 3 minus root 7 all over 2. So hope you see how the steps work together here. Multiply top and bottom by conjugate, FOIL. You're going to see that due to the plus sign and the minus sign, in the two things that you're multiplying together, the inner and outer term cancel. And so those are the places where there was perhaps some concern of radicals being left over, but they undo each other, simplify to a 0 anyway. Let's take a look at another example. Rationalize the denominator in 4 over root 6 minus root 3. The conjugate of root 6 minus root 3 is going to be root 6 plus root 3, so we'll multiply by root 6 plus root 3 on both top and bottom. The key thing again is in the numerator, if you want to distribute that 4, go for it, but you'll see I didn't do that. Instead, in the denominator, if you expand this out, root 6 times root 6, see that was a place where we maybe thought there'd be some danger of a radical still sticking around, but it's root 6 squared, which is just a plain old 6. No more radical. That's awesome. Then we have a minus root 18. Uh-oh, that's a radical. Oh, but we have a plus root 18. So in a future step, in just a moment, not right now, but in a future step, those will simplify, the middle two terms will simplify to a 0. And then finally, to finish our expansion here, we have a negative root 3 times a positive root 3. There'll be a negative sign. And then the root 3, well, it's root 3 times itself, or root 3 squared. That will be a plain old 3. Again, the radical is gone. At least in this step as written, I get a minus root 18 and a plus root 18. But let's now simplify that to a 0 in the denominator. Then really all that's left is 6 minus 3, which we did simplify to a 3 here. Key thing again is all of the things really worked out the way you needed, right? The point is in the 4 terms that are written out, by applying radical rules, the first term and the last term will no longer have radicals. The two middle terms might have radicals, but they're always going to be opposites of each other. And when you add those together, that will simplify to a 0. So this process always works, right? Okay, the interactive question for the day is meant to help address how the process of rationalizing the denominator in the fraction we just looked at and this other fraction, 4 over root 6, are different. So here's the question to answer. To rationalize the denominator in 4 over root 6, what must you multiply by on top and bottom? Okay, let's rationalize the numerator. I know this sounds strange. It says numerator. We haven't really talked about this, but let's put on a little bit of creative thinking juices here. Rationalize the numerator in 1 minus root 5 over 3. So now the idea is we should try to not have radicals in the numerator, right? So let's look at the conjugate of 1 minus root 5. This seems to be the hunch, right? Well, the conjugate is 1 plus root 5. And maybe we should take that 1 plus root 5 and try multiplying by that on top and bottom. Will it work? It'll work out. So here's how that looks. All these parentheses here are necessary, so 1 minus root 5 in parentheses, 1 plus root 5 in parentheses, all over 3 times, and then 1 plus root 5 in parentheses. So you see we took the original fraction and put parentheses where necessary so that order of operations didn't say something funky, and we multiplied the top and bottom by the same thing, namely 1 plus root 5. Now it's in the numerator where we really need to do that expanding out, and so we'll have 1, and then 1 times root 5 is a root 5, and then negative root 5 times 1 is a negative root 5, and negative root 5 times positive root 5 is a plain old 5. In the denominator now, I wasn't really worried about expanding here, and the root 5 and minus root 5 in the numerator, those will undo each other, so we have 1 minus 5, which will give us a negative 4. Now you might say, well, there's a radical in the denominator, and I'll say, well, yeah, there is, but now the task goes rationalize the numerator. So we have a fraction whose value is equal to the original, and at least there's no more radical in the numerator. I mean, the cost, in a sense, was we did some work, and the result is there had to be a radical somewhere. We just can't get rid of radicals in all the spots. So if the task was rationalize the numerator, meaning get rid of having radicals in the numerator, we had to settle for having a radical in the denominator instead.